In this video, we're going to be talking about activity 4.3, which is about revisiting a projectile. Projectile is anything flying through the air, so a ball, a rocket, a potato, whatever it is. So it says we have seen quadratic functions modeling the height of a projectile as a function of time, things being flown through the air. Here are two ways to define the same function that approximate the height of a projectile in meters t seconds after launch. Here is one of the equations written in standard form. Here's one of the equations written in factored form. If you were to do the box method with this and multiply it all out, you would get from here to here. They're the same thing, just two different ways to write it. Which of these ways of defining the function allows us to use the zero product property to find out when the height of the object is 0 meters? And if we're going to use a zero product property, that means that we're thinking about two things being multiplied together to equal 0, and then thinking about what value of x, or t in this case, would make each factor equal to 0. So that would be this one over here, because we have two things multiplying together, and we want to know when the height is 0, when it will equal 0. So we're going to say the factored form version. Factored form is really nice for using the zero product property because you can use it to find what would make each factor equal 0. So in number 2 it says without graphing, determine at what time the height of the object is 0 meters. So without graphing this, we can just look at this and we can figure out what, so we have this equation right here. Start over here. Okay, so we have that equation because we want to know when the height of the object equals 0 meters. It's on the ground. So to solve this equation, we need to figure out when does this one equal 0 and when does this one equal 0. Because if either of these are 0 and you're multiplying by 0, the output will be 0. So let's do this one first. We have negative 5t minus 3, and I can't do that in my head very well, so I'm just going to set it equal to 0 and solve it. So I add 3 to both sides, so I get negative 5t equals 3. Divide by 5 on both sides, so I get t equals, negative 5 on both sides, negative 0.6. So that's one of my times. So at 0.6 seconds in the past, essentially, which doesn't really make sense, it's not in our domain, this object would have been at 0. The other one here would be t, I should say, t equals 6, because 6 minus 6 would be 0. So of these two times, it says determine at what time the height of the object is 0. So the value of negative 0.6 seconds and the value of 6 seconds are the two times that would make this height equal to 0. This one doesn't make sense. We talked about a lot in Unit 6 that if you're talking about an actual situation with a context and you're throwing something in the air, the domain would be from 0 seconds to the time that the ball or whatever it is lands. This is before 0. This is in the past. So this one doesn't really make sense in context. Which means that that is the answer. So when it hits the ground. Okay? There we go.